Hello, AGers. We're going to take a look at 931 and we're going to look at systems of inequalities. Remember when we looked at systems of equations, we looked for the point where the two equations overlapped. With inequalities, we have shaded regions for our solutions, so we're going to look for two shaded regions that overlap. So we're going to start off with some nice friendly inequalities here to graph. I have the equation y is less than or equal to -5, and the inequality y is greater than 2/3 x minus 1. So for our first inequality, I have a y-intercept of 5. So there's my point, and I have a slope of -1. So I can just go down 1 to the right 1. And there's my slope. It's a less than or equal to, so when I draw my line, I'm going to make sure that it's solid. And because it's less than, I'm shading beneath the y-intercept. So this region here is going to be shaded. Now when I shade this, I'm going to keep it fairly light because I'm looking for an overlapped region. So now we'll look at the next inequality. Y is greater than 2/3 x minus 1. -1 is my y-intercept. My slope is 2/3, so I'm going to go up 2 and to the right 3. If I went in the other direction, I'd go down 2 and to the left 3. So there's a nice equation. Now this is a greater than. So it is going to be dash because the line is excluded, but I am going to shade above. So when I shade above this line, see where I've overlapped? So this region right in here is above the second inequality, and it is below the first. So when I'm looking at what do they have in common, all of these points would be solutions on both inequalities. So we will call this the double shaded. Okay? Normally when you look at it, you don't have to shade everything. You can just look to see where the overlap is and just shade the overlap. All right, so we're going to make sure that we've got this correct. If I look at the point 0, 0, it is in the double shaded zone. So if I have y is less than or equal to -x plus 5, and I want to substitute in 0, 0, is 0 less than or equal to 0 plus 5? 0 is certainly less than or equal to 5. So that works. It should also work for my second inequality. Y is greater than 2/3 x minus 1. 0 is greater than 0 minus 1 because 0 is greater than -1. So 0, 0 is a win. It's in the double zone, double shaded zone, and it gives me a true statement. So normally we do this sort of mentally just to make sure that we've got the right region shaded. Okay, let's give it another shot. So here again, I've got two inequalities. Y is less than x plus 2. I can graph my y-intercept. I can go down 1 and over 1. I could also just pick a friendly point when x is 5, y would be 7. So I go over 5, I'd go up 7. So these points that you're picking, you're just picking friendly points. If I went to, let's say I picked a negative number, if I went to -10, then my y would be -8. I'm going to draw my line. You got your handy dandy ruler. It is what kind of line? This is going to be dashed because it's excluded because it is less than. So for this one, I'm going to try to hold off on my shading to make sure, to see if I can do that prediction without, to see where the overlap. So these would be shaded down below. For my next one, if you want, you can rewrite it in slope-intercept form. I can see I have a y-intercept of 10, right? If I want to pick 4 for x, the 4's would cancel out. Negative 3 plus 10 is 7. So I would go up 7 from 4. So 1, 2. I could pick 8. I'd get negative 6 plus 10 is 4. So there we go. This is going to be a solid line, and I'm going to shade below. So both of these were shaded below. So I want to be below on both lines. If I'm below on this line, I'm coming here. Below on my first. So here we go. This is my double shaded zone. Only this area is a true statement for both, right? You can pick 0 and just double check. That's in my double zone. 0 plus 2 is greater than 0. 0 is less than 10 minus 0. It works. You're in great shape. All right, so now I've done 2 linear inequalities. Now I've got an exponential inequality, and I also have a linear inequality. And we've got the 2 graphs here. I can tell I've got my dashed line and my solid line. So the exponential equation is included, the linear equation is excluded. So why is the line dashed? Right? We just said if it's dashed, it's excluded. From solution. So, if I'm looking at all the different regions, I've got quite a few. I've got this big region in quadrant 1. I've got this little section up top here. I can go to the side here. I can go right in the middle, right? And I can go down bottom here. So I have 5 different regions, right, that I could have shaded possibly. So now we want to either look to see what's going to be included in the solution. So I'm going to look at my exponential inequality. It is less than, so that would be region 2 or 3, right? Or it could be part of region 5 here. So I'm looking at 2, 3, or 5 based on how I've numbered my regions. If I'm looking at a greater than for my linear, right, I could have region 1, 2, or 5. So which regions do they have in common? They have 2 regions, right? So this region, region number 2, and region number 5 are what they both have in common. So those are my solutions. So in this case, if I wanted to double check this, would I want to pick 0, 0? No, because it is it's not one of the shaded regions, and I can already see that it is on my linear equation, so it is going to be part of that boundary line. So not overlap, and it's on a boundary. So both of those makes it a poor choice. All right, we're going to take a look at the second page here, the flip side, and we're going to do a few more of these graphs here and see if we can come up with what regions they have included. All right, so okay, we got this. Here we go. Let's see if this camera will settle down. All right,